This is The Water Table.
A chance to hear the agricultural side of these issues.
A place for people to go find information and education.
Water management is just going to become even more critical into the future.
How misunderstood what we do is.
I would encourage people to open their minds and listen to this dialogue.
This week, we're taking the Water Table podcast on the road to Melbourne, Iowa. We will be visiting the Iowa Leica Farm and the Iowa Leica Field Day. Join us as we interview some great guests.
Well, welcome to the Water Table podcast. My name's Trey Allis, agricultural application engineer with Prinsco, and here today at the Iowa LICA Field Day down in Melbourne, Iowa, with Matt Helmers and Charlie Schaefer. Matt's the director of the Iowa Nutrient Research Center, has been working at Iowa State for a while within the Ag and Biosystems Engineering side. So Matt, you want to introduce yourself? I know you've been on the podcast a couple times, but give us a little background on yourself.
Yeah, thanks, Trey. And it's great to be back on the Water Table podcast. Anybody listening might not feel the same way, but it's great to be here. Actually, next week it'll be 20 years at Iowa State, and I'm a native Iowan from Northwest Iowa. Kind of joke, maybe I said this before, but I learned the importance of drainage at a young age, but didn't realize it. But have a picture in my office of my grandfather having his plow and two other tractors stuck on a side hill seep. And so, but it's great to be here at the Leica Farm. Been coming out here for a number of years. It's amazing the improvements they've made to the farm here with the wetland and ponds. And today we got to talk about saturated buffers with some contractors and the demo of installation of a saturated buffer. So look forward to talking about that.
Yeah, and we'll dive into that. But we're also here joined with Charlie Schaefer with AgriDrain, and I don't think I have enough room on my paper to go over all the other stuff that you're involved in. So maybe I'll turn it over to you, Charlie. What brings you here?
Well, Trey, it's a pleasure to be here with you and Matt. Really appreciate the opportunity. It's fun. I did get to do an earlier recording or two with Jamie, and that's always fun because we have so much history back and forth with our experiences in the industry. I grew up in a small farm in Guthrie County, 160 acres, and 5 brothers, mom and dad, and so we had 40 acres was timber, pasture ground, and we had a diverse row crop system, and got to see agriculture and the type of water issues you're talking about, Matt, with the wet spots and side hill seeps and waterways that had cut out erosion that was going on all the time, big rainstorms before we'd adequately protect those slopes, and so it's fun to be here at the Leica Field Day. We've been on this farm now about 20 years, and it's, for me, rewarding to see us match up not just the construction activities and moving dirt, but also the science behind it that Matt and his colleagues can bring to the table and help us think in maybe a little bit of a larger vision about what we're trying to accomplish out here for ag and the environment.
Mm-hmm. Yeah, and thanks both for sitting down here and taking the time to talk through some of this stuff. I know since I started at Prinsco here a handful of years ago, have had the opportunity to meet and chat with each of you a handful of times, and always appreciate the opportunity. And great people to learn from, and been very appreciative from that. But yeah, like you said, Matt, we're here at the Leica Field Day, and had a chance to cover some of what a saturated buffer is, as well as start the installation of it. But would you want to give a little background, from your engineering background, for what is a saturated buffer and what's its purpose?
Yeah, great question, and really, the genesis of it comes from some colleagues, Dan Janes, that was at the USDA ARS at that time, and Tom Eisenhart. And Tom had spent a better part of his career looking at buffers, and then he and Dan thought, well, a lot of that nitrate that we see is going in a tile line right below that buffer. Can we do something better? And started to think about, can we intercept that with a control structure? A lot of AgriDrain control structures. So that's where, it's been great to kind of that partnership between the academics that have some idea, and then to ask Charlie, and Charlie's always willing, yep, we'll try something, I think that's Yeah, you're willing to try things.
Matt,
So, right?
you
You
could
know, I mean,
fairly add that what we try doesn't always work.
that's exactly, but that's what we learn, right?
Right,
And you know,
exactly.
I think it's a two-way street, because we learned that something you guys did, not a great idea. You know, you thought of in the ivory tower. So okay, so you know, can we do something better? Can we run that? You know, divert a portion of that water that's coming down the tile line out laterally in a tile and have it flow through shallow groundwater flow below that buffer. And you know, the first was, what happens to that water? And you know, so Tom and Dan did work and found, wow, we get tremendous nitrate removal. They had graduate students like Tyler Groh and Morgan Davis that did a lot of research to understand the mechanisms of removal. And it's really built from there, where it's you know, this is really a success story, because 10 years ago, that was just a thought, like, can we do this? And now it's gone from, you know, research at one site to research at multiple sites to a practice that is really trying to be scaled up in Iowa through various programs.
And you mentioned that with a water control structure, and I guess I've never had the opportunity to ask, but you know, Charlie with AgriDrain, you are one of the leaders in you know, in those structures. How did you come up with it? What led to that design and invention of kind of damming up your tile lines to divert some of that water?
Well, you know, years ago, there was an effort undertaken by both ADS and Hancor to focus on the ability to provide sub-irrigation to some of these crops. And this was 35 years ago, I would imagine, and they each had their approach. And we worked with ADS at the time to develop some float-operated automatic water level control structures that could be used to manipulate water tables, flow rates, and add water back into the system. And at that time, it worked, it was fine, but there was no true automation that made it easy for the producers, and the economics were different. The value of corn was less, the value of land was significantly less. At that time, if I recall correctly, you could buy land for around $1,000, $1,500 an acre, and it would cost at least that much to put this system in. And so the producers made the right economic decision to buy more land, which was appropriate. And also weather patterns were different back then. You know, we had more normalized rainfall rates and timing, and so we didn't have those environmental concerns, the climate related or weather related concerns, and there certainly was no concern about water quality, because we hadn't really discussed the nitrate and dissolved phosphorus issue associated with subsurface drainage. And so we really started to develop these products for surface water application primarily. And there were ponds and wetlands, and people wanted to be able to manipulate those. And then we started, of course, adding in the subsurface water management thing, and it's gone from there. And there's been a greater focus on it due to the fact that the water quality issues are significant. So there's been public funding available because downstream folks are impacted.
Mm-hmm.
I guess one thing, not to add on the structures, but I think that we're kind of, I mentioned, I think that I've been at Iowa State 20 years. We're just a little past 20 years of a real partnership between the academics, the industry, and agencies with the what started as the Ag Drainage Management Systems Task Force and the Ag Drainage Management Coalition, now the Conservation Drainage Network. But for the last 20 plus years, at least once, or in the early years, 4 times a year, these people got together to talk about the water quality side of drainage, and really it kind of started around controlled drainage water management in a lot of the early years, and it's really broadened beyond that. Certainly that is still a really primary focus in a lot of areas, and Charlie and his colleagues are doing great work with some of the automated structures, but through the work of that group has really led to things like the saturated buffers, the bioreactors, wetlands for nitrate removal, and even the drainage water recycling that I would say is an emerging practice. Mm-hmm. So I think it's really a success story. We have so much work left to do, but I think it's a real success story of how we can all work together in this and learn from one another. Because as Charlie said, sometimes we come up with something that doesn't work very well, and we have to go back and change it. And that's what research is about, and that's what having a good partner in the industry is about as well.
I think it's very true. If I could add to it, what we did in conjunction with the task force members and the land grant system was to work with ADMC, the Ag Drainage Management Coalition, and applied for a Conservation Innovation Grant. First, we did it on drainage water management alone, and secondly, we did one on saturated buffers. And so we developed, I believe it was 16 sites through 5 states, and we intentionally selected some sites that we thought would not perform well, and we were right. They didn't. And so we got a chance to see what worked and what didn't work as we went through this study. And in addition to just doing the demonstration and testing these things, we put the distribution lines in the field at least 50 feet upstream from the ditch bank, and then we'd drill monitor wells at 15 feet downstream, 15, 30, and 45 feet, and test the water quality, and found really great results, as you mentioned, with this thing. A lot of the nitrate levels got below detention, or the ability to detect it, detection. And so that was really exciting to do that in conjunction with that Conservation Innovation Grant. We also worked with Laura Christensen at University of Illinois to do some type of scale up to say, well, what is the potential for this practice throughout the upper Mississippi River Basin? And if I recall correctly, in Iowa alone, there is an opportunity to cite something around 120,000 of these practices. And if you think about that, that's really remarkable, man. It's a lot of practices out there. It's a lot of outlets we can treat.
I think you're right. I don't mean to cut you off, but I get excited when I think of it that way, because we talk a lot about rural economic development. If we're going to put in hundreds of thousands of these practices, which I think we need to do, as we think about bioreactors, saturated buffers, wetlands, drainage water management, and drainage water recycling, that's a lot of work. That's a lot of rural, economic development for small businesses in these rural communities to put these in. These are going to be where we are today. The land improvement contractors are going to be doing that work. Small engineering companies, Ecosystem Service Exchange, some of the other smaller engineering companies are going to be the ones to design these. Prinsco is going to be involved with helping to, see these things go forward. So I just, I'm not considered. Nobody accused me of being an optimist, but as I think about this, I think we have a real opportunity, and there's some really exciting things as we think about scaling up these practices and rural economic opportunities for our small businesses in these communities.
Right, exactly, and that's kind of like what you've been saying before. Over the last 20 years, we've been researching some of these practices, been thinking about it for a while, and that kind of brings us to today where we're at here. I think we're at an opportunity within the industry is scaling up some of these practices, and I think about a lot of agriculture specifically. It always leads to more precision, more control on what you have on your land. And one thing that seems to get forgot about, or maybe misplayed or downplayed, is the water that you have on your land. And that's what, when you were talking about that, Charlie, with these structures, with drainage water management, that gives you the opportunity to control that resource, that water that you have on your land. That's where I see is kind of the next step, within agriculture, but specifically within the ag water management industry too.
Yeah, I couldn't agree more, and I'm encouraged by the fact that we're seeing more people focus on a systems approach. They're looking at the overall entire watershed and how it affects crop production and water quality, but also sustainability, the ability to farm and make a profit out of it, and reducing erosion and downstream impact, from flood mitigation to water treatment and purification. And if we really approach this market correctly, I think, with a long-term vision of what these working ag lands can look like and how we can manage that water for retention and storage and strategic shedding. We can do things in the drainage area that have been contrary to traditional methods here for the last 120, 130 years. It's kind of crazy to think about taking a resource like water, as dry as we are in many areas today, and just allow it to run 24/7 when you can look out in the field and see corn crops curling up from drought stress. And it's kind of ridiculous, actually. And recognize that the nutrients that we bought and paid for and put on that land are flowing out of that tile and with the water as well. It's wild. So we can do better. And we as an industry need to work with research and education and engineering folks and really step up to the plate and advance the cause.
One thing I guess mention about, talking out in the field today about the saturated buffers, this was an opportunity. A lot of times we have field days and there's farmers there, but this was great to have contractors there and to hear some of the interest from the contractors is growing, and had a couple contractors come up afterwards and say, this is something we need to be thinking about this fall. We're going to be putting some systems in. On each one of those, we need to be thinking, can we put a bioreactor or a saturated buffer in there? We need to be doing that while we're out there at that time, and that's where we have to get, is that this just becomes kind of business as usual, that we think about this practice right when we're putting that new drainage system in. So I think that that was my exciting moment for the day, I guess. Yeah.
Right. Yeah, and from my perspective with a lot of this too, from the engineering side, is say a saturated buffer, which we looked at today. It's a pretty simple practice. All it really is putting in some perforated tile lines parallel to a ditch bank or to a wetland, and allowing the media, that soil in between the field and the stream and the water to filter out the nitrates. So you divert some of that water through there, and that treats it in the process. And that is encouraging to hear that there is more buy-in, more people thinking about that of, hey, if I'm here doing some tiling or doing some other water management within this location, and I know I have an outlet coming in here right on a ditch that has a buffer in it, it doesn't take a whole lot of again, in theory, we can talk a little bit later in a different episode about some of the funding mechanisms and some of that stuff that's available for it. But from a pure tactical standpoint, is you're just damming up your water a little bit, allowing that water to be filtered out into the stream, and in the process get treated that way, without affecting a whole lot that's going on the field itself.
That's exactly right. Yeah.
I think the funding is an important element of this as well, and the point was made today by IDOLS that these practices are fully funded by state and federal dollars. That the state of Iowa is leveraging federal NRCS USDA dollars with the EQIP program and RCPP and others to get this on working ag land at no cost to the landowner, because the primary benefits are downstream.
Yeah. And I think that, we talked about it a little bit there, but kind of thinking about this, a one-off approach, when you talk about how many thousands of potential sites, we need to think about new delivery mechanisms. And so I think that's also exciting. Not only in the last 10 years have we learned more about the research on some of these practices, but there's kind of adaptive management of how do we best go about getting more of these practices on the land. And so there's batch and build efforts in place in Iowa, there's turnkey up in Minnesota, and so I think really thinking about how do we efficiently get these out there, make it easy for the landowner, so that there's reduce that hassle factor of having to do this, and make it easier for the contractor, so that it's not just one-off jobs all the time on some of these edge of field practices. So that's been exciting to see how there's been some innovation in that space. What's worked in the delivery mechanism for the last 30, 40, 50 years is kind of being changed to try to scale up the adoption of these practices, and that's pretty exciting.
Mm-hmm. Yeah, and even better, like you mentioned, if you're designing that, or when you're installing or designing your tile system from the start with that in mind, of being able to implement some of this stuff, get that ball rolling earlier on in the process, that's kind of the overall goal and eventual goal, and something if we keep going that way, and I think that's one of the main purposes of this podcast, is to help educate the public, but then also the contractors, like you mentioned, a lot of people that are here today, on how simple some of these practices are, how effective they are, and it's kind of the next step in the industry, I believe.
Yeah, you're exactly right, and I think that we talk about this in a lot of our educational events. I still remember back to some ADMC training on controlled drainage water management. It is better to design for these things in mind, even if you're not going to put them in place right now. Even if you're not going to do controlled drainage right now, lay that field out as if you would, because it is a lot more of a challenge to come in and retrofit those systems. If you're thinking, okay, well maybe I'd put a bioreactor in, and you might normally design your system with a couple outlets to the stream, or same with saturated buffer. Now let's design it so that we can get it maybe all to one main and be able to treat that. So I think that, even if it's not something that you have everything in place to put that practice. Design it as if that's going to go in the future, because it sure will make it easier, I think, for that contractor to come in and retrofit if they've designed with that in mind, rather than design, as maybe we've done for the last 30 or 40 years, and then we want to retrofit it.
Couldn't agree more. And we probably have a historic opportunity here in Iowa. As we look at the Des Moines Lobe, there's almost 10 million acres there that was kind of squashed down, flattened down by the glacier that came in and receded about 12,000 years ago. And it's been drained, but much of it has been targeted to random drainage. A lot of it is undersized for the types of weather conditions we have today and the farming practices we employ. And so as we see those systems age out and become replaced, it'd be a missed opportunity if we don't take advantage of designing those correctly. So even, you're right, Matt, if we don't manage them today, we're in a position to manage them. And our CS dollars are available at the initial phase and or at retrofit, but it's certainly much easier and more efficient to do it in real time as you're designing and installing these things.
And the way I think about it, the way that you design them for sub-irrigation is similar to controlled drainage, but then every sub-irrigation system also has controlled drainage. Every controlled drainage system also has that aspect of free drainage when you need it too. So, when you are designing it in that way, you're not really out anything compared to how you would on a conventional drainage system.
You're exactly right. That's exactly right. We can still do the things that we normally do, but it provides us opportunity to enhance our system in the future.
Mm-hmm. That's right. And if we can utilize that drainage water management or sub-irrigation system to reduce about 50% ballpark of the volume of water and the nutrients that come out of that field over the course of a year, and then we can route that 50% of the water through edge of field practices like saturated and buffered bioreactors and take another 50% off, we're down to 25%, dramatically impacted the outcome.
Mm-hmm. And you want to talk a little bit, Matt, you mentioned it here earlier today on the effectiveness of some of these practices. I'm thinking specifically the saturated buffers and bioreactors.
Yeah, that's a good question. I'm not sure I'll have my numbers exactly correct, but we're somewhere in that 30 to 50% removal of the water that would have otherwise been discharged downstream. In the saturated buffer, that water that goes out to the lateral and then moves below ground to the stream, we almost get complete denitrification or nitrate removal, as Charlie mentioned. It's just that we bypass some of that water flow. So even when we account for that bypassing, we're in that 30 to 50%, kind of in the same range for bioreactors, and similar for wetlands as well. And so they all function really quite well. We're in that probably 50% for controlled drainage as well. So they all perform really well. And what I say is that, or think about, is that not each farm is going to be suited for a saturated buffer or a bioreactor or wetland, but each farm may have a practice that works, and it's trying to find what practice works for that specific farm. If you have drainage, if we're in the non-drained area, that's a topic for a different podcast, maybe not the water table, but if we're in the drained landscape, I think each farm has the potential for one of these edge of field practices to treat that water before it's exported downstream, and it's kind of looking at what fits into your specific farm and farming operation.
Yeah, we see folks occasionally now, as you mentioned, capturing the drainage water that's coming off of these things. We did the Transforming Drainage Project, 5 years, $5 million, sponsored by the National Institute for Food and Agriculture. A big success, and really demonstrated how we could design these systems and manage them in an effort to really control almost every aspect. Yeah. And then when you take that drained water that comes out off the field or out of the drainage system, and you recycle that back through as a sub-irrigation system and put those nutrients back in the field, you really increase your outcomes.
Yeah, now you're going to get me excited, because that's like the practice, that we've talked about. Yeah, that's right. I get all, we talked about these other practices, and they all have, in my mind, the benefit is to that water quality, that downstream user, but there's not a direct benefit to the farmer. And the holy grail would be, do we have a practice that not only benefits water quality but could provide benefit to the farmer on some of these? And so one that we're looking at, colleagues in other states, is this drainage water recycling. Can we capture some of that drainage water and use that for supplemental irrigation, either sub-irrigation or overhead irrigation. And I think that, we are then taking that water and the nutrients in that water that would have otherwise gone downstream, and we're putting it to use out in the field. And certainly as we think about kind of some of the changing climate with wetter springs and drier summers, having a few inches of water this time of year, late July and into August, really could, help us reduce yield variability in our fields and maybe enhance that yield. And so we're starting to look at that at 3 sites in Iowa. We're excited about that. And we've seen, over 5-6 years, about 30 to 40 bushel yield benefit on average for corn. Now, a lot of that was influenced by one year where we had 100 bushel yield benefit. But, I think we still need work to look at the economics of that system under, kind of different scenarios of how we place that storage and so forth. But, really excited that this is a way, kind of a full-scale water management system that we can, reduce that downstream water flow and enhance crop production out in our fields.
Mm-hmm. So yeah, we covered just about everything, I think, with water management on the ag side, and I appreciate it. I always have a good time talking with you guys about this stuff, but hitting on saturated buffers and drainage water management, sub-irrigation, bioreactors, all of this stuff. That's a lot of stuff that we have been working on for a while. But what else do you guys see kind of coming down the road as far as within this realm? Is it just more scaling up of these practices, or whatever from a research side? Or I know, Charlie, you're really innovative. What do you see coming down?
Well, we're seeing good opportunities in automation. As we can drive sensors and valves and monitor the conditions in the field, we look forward to improvements there. It makes it easier for the farmer to be really aggressive in their management, active management. We're looking at trying to do a better job of prescribing the right management style for them, and even get a little bit forward thinking in looking at forecasts, weather forecasts. Do we drain if we're irrigating? Do we wait to irrigate if we've got a rainfall event coming towards us, or a high likelihood of that? We can save the money that it would otherwise cost to drain. We believe that as we can better monitor and quantify nutrient reductions, we'll see these environmental markets mature and give these producers more reason and more incentives to participate in these markets. That's exciting. There's a lot of work being done on phosphorus too. We talk a lot about nitrogen, but phosphorus is a big driver in a lot of watersheds. And there are traps and containment chambers for those, and we're looking even how can we blend that type of technology into a saturated buffer at an affordable rate. And so there's lots of fun stuff going on there as well. This is a tremendous opportunity, and a lot of financing available now. We look at greenhouse gas reduction. Matt, you know a lot better than I about how drainage water management can impact that. But climate smart ag, with the Inflation Reduction Act funding going to NRCS now, is a neat opportunity, and it really presents us with a funding mechanism that is significant, and we can take advantage of some of these opportunities.
Yeah, it's a good question, Trey. And so I look at it from as a director of the Iowa Nutrient Research Center. There's a lot of research still yet to be done, but that should not prevent us from scaling up. We know enough to really scale up. So I think we'll be looking at new practices or new ways we can implement practices. We have a project that we funded through the Nutrient Research Center looking at can we design grass waterways a little different to maybe implement some of this saturated buffer concept and use some of these grass waterway areas as opportunities for denitrification. So, this is a case where maybe it will work, maybe it won't, but I think we need to be looking at that because there may be some unique opportunities. I also think that, I'm hopeful for the future on the research side to be able to document that we can have a watershed scale water quality impact from implementing these practices at the scale, because I think that's a way we can show citizens of our various states that yes, when we implement these practices like we want to do, that we can see the results that we expect. So I think there's going to be a lot of opportunities on the research side to do some of that, and then thinking about continually adapting how we scale this up. How do we adapt so that we can get the most practices out there in the best locations and kind of the least hassle for the farmer. So I think there's a lot of opportunities to do that, and I wish I knew now what new practice is going to come about, because 10 years ago we didn't have saturated buffers. So somebody more creative than me will probably come up with some new practice that 10 years from now we'll be saying, wow, look at how that practice has helped us.
Mm-hmm. Covered a lot here, and there is a lot of information that's out there, and like I said, decades worth of research and experience from all this stuff. There is tools available from an educational standpoint. That's one of the reasons that we came out with the Water Table, not only the podcast, but we also built out watertable.ag to house some information on the practices, on the research, on some of that stuff too. So also the Conservation Drainage Network, there's a handful of extensions for the land-grant universities. There is a bunch of this information that is out there, and then also I think we're all open for questions on all that stuff independently and be able to talk through it. So it's been a fun opportunity here chatting with you guys, being out here with some of the contractors and with some of the LICA folks to keep spreading the word and keep educating people on what's all to come and what has been happening, and kind of show off a lot of your guys' work and a lot of what we have going on in the industry. So with that, I guess, do you guys have any final words, any takeaways?
I just appreciate what Prinsco and you're doing, Trey, you and Jamie and Kent and the gang. I think to get the word out, not just to our industry, but beyond that, to tell a story. And I think it's an exciting opportunity, and do appreciate your efforts to promote it.
Yeah, I certainly echo that, and to highlight, I think there are a lot of resources out there. We do some work within ISU Extension and Outreach with the Iowa Learning Farms program. We do a weekly webinar. If you go back and look at those archives, there's multiple webinars on bioreactors and saturated buffers. In fact, you could go back maybe 10 years ago with Laura Christensen on a bioreactor. Laura looked, we all looked a little younger then, but those are all archived, and we also have some virtual field days. So sometimes it's tough, for contractors or others to get out to see one of these practices being put in place. We've tried to, this is where COVID was, we learned something from that. We can take some of these to people, and so doing some video recording, so you can go look at the virtual field days there as well on some of these practices on the Iowa Learning Farms website or YouTube page.
Mm-hmm. Awesome. Well, thanks again for your time here today, and also for all your work that you've been doing throughout the industry. It was a pleasure to have you on, and a pleasure to stay in contact with you guys.
Thanks
Appreciate
a lot.
it.
Thanks again, Trey.
Thanks, Trey.
Well, thanks for listening to this episode. I have so much fun recording these. I hope you have as much fun listening as I do recording. These episodes are available on all major podcast platforms as well as YouTube. So find them and download them when you can. Thanks for joining us.